Well, thank you for joining this South Central Texas Fall Climate Outlook webinar. My name is Larry Hopper, and I work for the Austin-San Antonio Weather Service office here in New Braunfels. So just to kind of give you a quick overview of the 2017 Atlantic hurricane season thus far, you can see that back on May 25th, NOAA was predicting that we would have a little bit above average season with 5 to 9 hurricanes, which is just slightly above the average of 6. And 2 to 4 major hurricanes, which is right kind of where we would expect on an average year. But as we went to early August, there was an increased tilt that NOAA decided we should increase the tilt in the odds towards above normal because conditions were becoming a lot more favorable in the main development region in the Atlantic just off the coast of Africa all the way to the Caribbean Sea in the form of weaker shear and higher sea surface temperatures. And in addition, we expected that El Nino would have some potential to occur back in the springtime. Well, as time went on, it became more apparent that that was not going to occur, and we were going to remain in ENSO-neutral conditions. So as a result of all those factors, NOAA in their August 9th outlook actually increased the number of hurricanes that were expected to 14 to 19, keeping the number of hurricanes the same, but also increasing the possibility for another major hurricane. And so as you can see, up to this point, we've had 13 named storms, which is above the average. Technically not within the range that they predicted, but hurricane season goes through November 30th, so there's a good chance that we will eventually reach that number. We've had 8 hurricanes, which falls between the 5 to 9 range that they gave, well above the average of 6. And we've had 5 major hurricanes that's at the upper end of that average up to this point, which is well above the average of 3. And so just kind of reviewing what happened back towards the end of July and most of August, if you remember back to the summer outlook, we said that El Nino and La Nina tends to have an effect on how many hurricanes tend to form in the Atlantic basin, but where they go is strongly dependent on the position of the tropical ridge of high pressure that is often located somewhere around Bermuda or somewhere to the east or west of that. And so when you take a look at the negative phase, which is what we went into during late July and August, typically during that time, the subtropical ridge tends to expand a little bit further to the southwest and shifts in that direction, and therefore that prevents hurricanes from recurving northward and over to the east coast of the United States or back into the Atlantic, and it really puts them into the Caribbean Sea and eventually into the Gulf of Mexico. And so Harvey, which was what we call a Cape Verde hurricane, it developed well off the coast of Africa in the earlier parts of August and middle August as kind of a weak wave that briefly reached tropical depression storm status. And then as it went further towards the Yucatan, it briefly weakened again, and then redeveloped as it crossed the Yucatan and went into the Gulf of Mexico, where obviously it rapidly intensified as it went over kind of a loop current that had split off from the main loop current further east in the Gulf. And so that's a big reason why we knew that this wave that ended up becoming Harvey had a good chance of hitting the Mexican or Texas coast. Just was a matter of how much it would intensify, and in this case, it intensified quite a bit. But the steering patterns were very much affected by this tropical high position and the North Atlantic Oscillation. It's not a big secret that Hurricane Harvey produced torrential amounts of rain across most of southeastern and south central Texas. If you take a look at this rainfall map, you can see this dark maroon line right here kind of delineates areas that had 10 inches of rain or more to the east and less than 10 inches of rain further to the west. And you also can see in these greens and these yellows and these oranges the very tight gradient that occurred between very little rain, less than 3 inches if you look where this green line is to the west of that, and 3 to 10 inches in that tight gradient that's about 10, 15, 20 miles wide, and then the 10 inches or more with the maroon into the east of that. And so a lot of rain over the eastern half of our county warning area from areas from eastern sides of San Antonio further west. Very little rain in some cases, less than half an inch to even possibly not any rain at all in portions of Maverick County. Of course, the maximum rainfall amounts were 29.19 inches here in northwestern portions of Fayette County, and of course that is where we had the Colorado River rise to its highest levels just about 54 feet since 1913. And of course, we can't forget what happened in Houston. That was a location that received anywhere, in some cases, from 40 to 50 inches of rain, and we've even had some reports in excess of 60 inches in the Golden Triangle region in far southeast Texas and Jefferson County. So certainly a rain event that we remembered for quite some time. And of course, from a weather standpoint, you can see that the rainfall anomalies that we've had, really from a climatic standpoint, over the last 90 and 180 days really do show that rain pattern from Harvey. So the areas that received Hurricane Harvey's rainfalls are quite a bit above normal. areas further west, if you were to look at this map even 5 or 6 days ago, would have been rather dry. We would have, in some cases, had less than 50% of normal in the parts of the Rio Grande Plain. So because of the large amounts of rain we've received for the past 5 days or so, that rainfall deficit has largely been removed at both the 90 and 100-day time scale. We do have some isolated spots in portions of the Everest Plateau, Rio Grande Plains, and Western Hill Country that are slightly below normal, but nothing like what it was if you were to look at this just over a week ago. And so therefore, because of our recent rainfall from Hurricane Harvey and over the past week out west, we're not really expecting to have much of a chance for drought conditions to redevelop, even though, as you're going to see, we are expecting a dry fall due to moving into a potential La Nina pattern. But one thing to kind of review is that as we went through the summer, we did have some short-term drought conditions that developed due to a very dry late June and most of July. You actually had some locations here in portions of our central county warning area, particularly on the I-35 corridor, that did actually have a D1 to D2 conditions. And so that quickly resolved itself after we got some rain in the first half of August, a nice rain event that occurred on I think the second Monday of the month. And then, of course, after Hurricane Harvey, you can see that most of Southeast Texas, really all of Southeast Texas, has no drought at all. And we started to see some clearing up of the drought conditions and abnormally dry conditions out west back on Tuesday when this drought monitor came out. And we do expect that probably even more of this will eventually be removed, and potentially even the drought conditions, a little tiny portion of drought that we have here in western Zavala County because of the rainfall that's occurred. So again, even though we may have a dry fall because of how much rain we've received over the past 5 weeks or so with Harvey and the last week with the rains that we had that were associated with moisture from Tropical Storm Pilar, that has really helped out quite a bit. And so just one thing to get into why it's going to be dry is going to be heavily dominated by the ENSO cycle. And so I know back in the summertime, back on June 1st, when we gave our last Outlook webinar, we thought that there might be a chance that El Nino would continue to develop. But we were also thinking that there was a pretty good chance that things would stay ENSO-neutral, and it did stay ENSO-neutral. And not only has it done that, but we've also started to see our East Pacific sea surface temperatures start to decrease quite a bit. And so right now, we're in the Nino 3.4 region, where we look to see what those sea surface temperatures are doing. We're technically just below the negative 0.5 degrees Celsius threshold that we need to see for 5 months in a row of that 3-month average in order to be classified as La Nina. But as you go further to the east in the East Pacific Basin, you can see that temperature anomalies on average are generally about 1 degree Celsius below normal. And so one way that this differs from last year is that this particular year we're having a more traditional La Nina pattern where most of the cooling is happening in the eastern portions and the east central portions of the Pacific Ocean, whereas last year we had more of a cooling signature just over the central portions of the Pacific, what we call more of a Modokai pattern. So we would expect that if this La Nina does continue to develop, that it should have more of a traditional response as opposed to what the Modokai did last year, even though the Modokai really did give us our dry and warm conditions last year as well. And so because of what Climate Prediction Center has been seeing with this, they have actually issued a La Nina watch just last week, primarily because if you take a look at this yellow line right here, this yellow line kind of shows the dynamical model average, which shows that we'd have about 5 or 6 months just below that La Nina threshold. The Cisco models, on the other hand, are not necessarily showing that. They're still keeping us in ENSO-neutral. But when you look at the CFS dynamical forecast and all of its ensembles as well, most of those even show not just a weak La Nina, but even a moderate and potentially even a strong La Nina. And so based on all these things, but also taking into account the Cisco models keeping us in ENSO-neutral conditions, CPC has predicted a 55 to 60% chance of La Nina developing this fall and lasting all the way into the winter, which would be different from last year, because last year's La Nina developed relatively early and then also ended pretty early in the winter. How does La Nina affect our weather? Well, the big way that it affects it is it helps to build a ridge of high pressure into Alaska over the northern Pacific Ocean. And downstream from that, we tend to get a lot of northwest flow that comes off the Intermountain West in the western portions of the United States. And that is going to be a more dry type of pattern for us. And of course, typically we see that the polar jet is going to remain displaced quite a bit further to the north. When that does happen, we don't get a lot of the really cold air intrusions that we typically see during winter, particularly in an ENSO-neutral year. But even on top of that, we're not going to expect to have a lot of opportunities for precipitation because we're not going to have a very active subtropical jet, and of course the polar jet will remain to the north. And so for these two reasons, we tend to stay relatively dry and warm. And of course, La Nina has its greatest linkages in the later parts of fall and into winter. And so the Climate Prediction Center's outlooks are going to largely reflect that in the long term, but in the short term, we're still going to be expecting to see, once we kind of dry out here for the weekend, we will end up having a return in Gulf moisture by this, beginning to middle of next week, with some decent rain chances for most of the region, probably better the further south that you go. And then we do expect to get some sort of weak wave or some sort of northwest flow pattern for the second week of October or towards the end of next week. And that will give us more dry conditions, but we're not really expecting to have a strong front come through. And so therefore, it looks like the warmer than normal weather is going to continue well into at least the second week of October before we might get some relief from that. One thing to look at beyond that would be the experimental 3- and 4-week outlooks that have been performing relatively well, and these have been issued for about the past 2 years. They've always been issued every Friday between 2 and 3 p.m. So if you want to get the latest on what that looks like, you want to look after that time. But when you look at this, you're seeing that down into weeks 3 and 4, which puts us right in the middle of October. They're predicting that we will have some cooler than normal temperatures, or at least the odds tilted towards cooler than normal temperatures during that period, suggestive of some sort of potential ridge over the west and some trough over the eastern United States, which would keep us in a northwest flow pattern and potentially bring us some fronts. And of course, you also notice that we're not really expecting to get a lot of precipitation as the odds are tilted towards dry normal conditions. And so based on those two things, we would expect that the middle of October might potentially, if this was to verify, be a little bit cooler than normal and drier than normal. One thing to point out about these particular forecasts is that, unlike the seasonal, monthly, and short-term outlooks that use 3 different categories of below normal, and near normal, where near normal is actual forecast based on skill. In this case, they don't forecast near normal, they just forecast above or below in 2 different categories. And if they have these white areas that say equal chance, it just means that they don't have a strong preference either way. They're not really necessarily predicting that it will be near normal, they're just saying that we don't have a strong sense of whether it will be above normal or below normal temperatures or drier or wetter than normal. When you look towards the long-term outlooks, the long-term outlooks for October are kind of what you'd expect. For temperature, if we're going to have, warmer first 10 days or so, and then potentially some cooler conditions past that, and then beyond that might be maybe somewhere in between, they've got us tilted towards near normal. Odds are tilted towards near normal temperatures for October. And of course, also expecting us to have a slight tilt towards a drier than normal October. But really, as we move through deeper into fall and into early parts of winter, CPC is really expecting us to be quite a bit above normal temperature-wise, or at least have the odds tilted towards above normal temperatures rather strongly, with odds also tilted towards drier normal conditions, which would be very indicative of what you'd expect for La Nina. But La Nina is not the only thing that's driving this forecast. In addition to that possible development this fall, they're also considering the longer-term temperature trends, particularly over the past 15 years since about 2003, relative to the full 30-year climate normal period that began in 1981 and ended in 2010. As you can see here in the fall, most United States actually has been much, much warmer the last 15 years than over that whole 30-year normal period. And it's like that in almost every season, including spring and summer, really like that for the Western United States in summer. The only season where we don't see a strong temperature trend is in winter, although we do have a weak trend over our region. But really, when you combine the fact that we have La Nina on top of this general warming trend, it makes CPC's forecast fairly confident that we probably will be warmer than normal this fall. And just kind of reemphasize this, if you look at our October through December temperatures during La Nina years, where this black line that's horizontal is the average temperature of 62.1 degrees Fahrenheit, you notice that this blue line, the trend line, going back to 1975, actually shows that we've been warming at about 0.7 degrees Fahrenheit per decade, or just over 2 degrees over the last 35 years or so. And so when you take a look at all the different circles here, there's 13 of them representing the La Nina years, or the years that just barely missed out by 1 month of becoming a La Nina, but were ENSO-neutral years that were very close to that threshold. You can see that 10 of the 13 are above this horizontal line with above normal temperatures. And even some of the ones that are below the trend line, especially here since 2008, 2010, and 2011, 3 of the last 4 La Ninas actually, you can see that even though they were below the trend line, they were still above that climate normal average. So the confidence that we're going to be above normal is fairly high for this particular fall and winter, early winter season. One other thing to point out too is that we are having our second La Nina in a row, just like we had last year. And the last times this happened in 1984, 1999, 2008, and 2011. In all four of those cases, we technically did have above normal temperatures, which gives some increased confidence to that as well. From a precipitation standpoint, once again, you see with all the circled years that were La Ninas or just barely missed being a La Nina by 1 month, you can see that in 10 of those 13 cases, we once again were not just below normal, but in many cases quite a bit below normal. And just like in 2016 for temperatures, when we actually had our warmest year with a 66.6 degree Fahrenheit temperature for the October through December period, we once again had a drier than normal year. And so we expect the odds to come true. We would expect once again to have drier than normal conditions. Having said that, we want to make sure that we point out in 1998, when we did really have just one very big rainfall event in the middle of October that year, that is actually the flood of record for this region, especially during the fall. That really just takes one event to really push us over the edge and be above normal sometimes if we get an event like that, similar to what we had this past week just occurred out in the Rio Grande Plains. And so on that note, we want to make sure that we reemphasize that this is the fall, and so September, October, November is kind of the peak of our secondary flood season. And also we do have a small peak in tornado reports during that time of year as well, though it's much less than what you see over here in the spring. But why do these flood events happen? Well, these flood events happen for the same reason it just happened this past week in the Rio Grande Plains. We tend to have a multitude of factors that are really set up by deep, low-level Gulf moisture, which we tend to get quite a bit, combined with the upper level and mid-level Pacific moisture, which you don't get as often. When we get that together, we have a very moist atmospheric profile that allows us to have a lot of heavy rainfall. Combine that with a slow-moving upper-level disturbance and a slow-moving front, and that upper-level disturbance oftentimes is very large as well. Doesn't move much. You take a decaying tropical system, which in this case was Tropical Storm Pilar over the past week, and you get a very heavy rain event that lasts for several days. In the case of this past week, you can see for all the areas that are kind of this dark orange and red area, had at least 4 inches of rain and really widespread 4 to 8 inches with some isolated 12 to even 16 inches of rain here in southern parts of Dimmitt and Zavala County. And even over our CWA border into Webb County, there's some reports that are above 20 inches. So when this occurs, you can tell that it produces a lot of rain for several days. And if you imagine that this had been pushed just 50 to 75 miles further to the east, that could have been very impactful for the I-35 corridor as well. And so keeping that in mind, we do want to make sure we keep flash flooding as normal impacts for October, mainly because we have had a lot of recent rainfall, which will keep our grounds saturated and our stream flow a little bit up, particularly over the western counties. But as we move through November, December, we're generally not expecting to have a great chance of a flood event here this fall. We would expect that we have less rainfall, and therefore our flood threat should go down as we go into November, December, at least below what it normally is. Having said that, we want to reemphasize that our biggest flash flood event during October has occurred during La Nina back in 1998. But in general, when you look historically, only 2 of the top 10 two-day rainfall totals in Austin and San Antonio actually have been during La Nina years. Most of them are during El Nino years, and same when you look at our monthly totals. 3 of the top 10 were La Nina years, whereas most of the others were during El Nino. So not really a pattern where we expect to get a lot of heavy rainfall. From a fire weather perspective, this rainfall has really helped to make sure that our fuels are a little bit more moist than they were before. But because we are expecting warmer than normal temperatures with drier conditions, we do expect those fire weather conditions will gradually increase towards normal by the end of the month, and then even possibly above normal in the hill country for November and December, because those particular areas have energy release components that are going to be a little bit higher because they have not gotten as much rainfall. And if they continue to be dry, you can even see from the map here for significant wildland fire potential outlook. The further north you go, particularly in November, December, the greater fire weather threat that we have. But again, the Rio Grande Plains and the Central Texas energy release components are quite a bit below normal, particularly out in the Rio Grande Plains. Then finally, for severe weather, we really don't expect to have a very active polar jet or subtropical jet, so that will give us less opportunities for severe weather. And really looking forward to the next few weeks at least, this is the severe weather guidance dashboard output by the CFS model that the Storm Prediction Center helps run. Here's the link for that as well, highlighted in yellow if you want to look at that on your own. You can see that we don't really have anything that's in the yellows and oranges and reds. It's pretty much all blue, which means that for the most part, we just don't have dynamic conditions that are very favorable for supercells to form. And on top of that, we would have precipitation with those supercell formation if they were actually able to form. And so that keeps our odds for having severe weather in the form of hail and damaging winds and potentially tornadoes down. But if we do get a particular event that can occur later on into the fall and early winter, I want to point out that Ashton Cook and others at Storm Prediction Center had done research on this that essentially shows that even though we have fewer severe weather opportunities in La Nina, when we do get them, they tend to have the potential to produce stronger and longer track tornadoes. So we don't want to keep that down too much. We want to make sure we keep that normal just in case an event does happen. And so finally, just kind of summarize our winter outlook is probably going to be on Thursday, December 7th. And again, we're expecting to go from borderline ENSO-neutral conditions this winter, just like last winter, into La Nina. And that's going to tilt our odds towards a warmer and drier normal winter, as you see here with the CPC's temperature forecast and precipitation forecast. So with that, we'll go ahead and take any questions you may have. And thanks again for joining us on this webinar.